For 10 years, French scientists hauled instruments across the Andes in pursuit of scientific vindication. But what they found was danger, betrayal, and survival against the elements. In the Age of Enlightenment, one scientific debate remained unanswered. What was Earth's true shape? Isaac Newton had proposed that our Earth was flattened at the poles, an oblate spheroid. Jacques Cassini believed the opposite. What might appear as a minor dispute had massive implications on both navigation and cartography. Driven by national pride, King Louis XV and the French Academy of Sciences began preparations for two missions. The first would head north to Lapland and was led by Pierre-Louis Maupertuis. The second was led by Louis Gaudin and would traverse the Atlantic to take measurements along the Equator in the Spanish Viceroyalty of Peru, better known today as Ecuador. If the Earth were to be flattened, a degree of latitude would measure longer near the poles and shorter at the equator. Simple in theory. The equatorial mission was international in scope and included a dozen French and Spanish crew members. Among them were Louis Gaudin, astronomer and expedition lead, Pierre Bouguer, known as the father of naval architecture, and Charles Marie de la Condamine, mathematician and explorer. They were accompanied by two Spanish naval officers, Jorge Juan and Antonio de Oya, along with French botanist Joseph de Jussot and French naturalist Jean Gaudin, cousin of the expedition lead. Their voyage began in May of 1735. Crossing the Atlantic, they landed briefly on the coast of Colombia. It was here that the first of many difficulties would manifest. Their expedition leader managed to place their mission into immediate jeopardy, burning vital funds on a diamond for his mistress in a Caribbean brothel. A decision that would later haunt them. Nevertheless, they continued sailing to Panama, traveling overland to set final sail toward Ecuador through the Pacific. Upon arrival, they were met with dense rainforests, slowing their trek inland. It wasn't until June of 1736 that they managed to reach Quito, where their team would have access to the Andes. Initially, their plan seemed simple: locate a high valley suitable to measure a degree of latitude. But the scientists wanted extreme precision and strove to measure 3 degrees. To do so, they laid a 120-mile-long set of virtual triangles as surveying stations across 3 mountain peaks. However, this was the point where the mission would fall into complete disarray. Terrain in the Andes was unforgiving. Cliffs, canyons, and volcanoes were all persistent challenges. The nearby Cotopaxi volcano was even observed erupting twice during their stay. Earthquakes would disrupt their readings and delay calculations. Then, the weather. Camps were buffeted by howling winds, freezing temperatures, and torrential rainfall. Tents were shredded during a severe storm, forcing the team to seek shelter in a nearby ravine. Snow would swallow the mountaintops, grinding their progress to a halt. Finally, the environment. Fever had claimed the life of their youngest assistant, Jacques Couplé-Vigour, mere days after their survey had begun. Severe altitude sickness claimed 3 additional members on the stratovolcano, Chichen Itza. Indigenous porters had been forced into servitude, leading to routine desertion. Instruments broken. Supplies bare, as their funds were fully depleted, leaving the team reliant on local support. Unfortunately, that support was tenuous. During a dispute, one of the Spanish officers shot the Secretary of Quito's president, leading to threats of arrest, causing them both to flee. In 1739, during an annual fiesta and bullfight, the mission's surgeon, Jean Seigneur, fell victim to a dagger in the spleen during an altercation with locals, passing painfully over the following days. And the scientists themselves? They slowly began to turn on each other. Godin alienated the group, eventually abandoning them. He departed for Lima and became a professor, helping rebuild the city following a major earthquake in 1746. Bigour and La Condamine feuded bitterly, accusing each other of falsifying data and poor mathematics. In their reconciliation, errors were indeed discovered, further delaying their expeditionary results. Despite everything, their science prevailed. Over the years, they had measured hundreds of baseline triangles. They timed the swings of pendulums at different altitudes. They recorded magnetic variations and studied barometric pressure. They invented modern geodesy, and in the process, laid foundations for a standard that would later become adopted as the meter. By 1743, the results were clear. The arc of a degree at the equator was indeed shorter. Newton was right. Now, they were set to return with their findings. The expedition was fruitful with secondary discoveries. La Condamine studied the properties of rubber and mapped the Amazon from source to delta on his voyage back to France. He was also the first European to thoroughly document the ruins of Ingapirca. Jussieu researched and documented plants such as the cinchona tree, the source of quinine, which was later used as an anti-malarial treatment. Ulloa and Juan published extensive works on Incan society, mining, and natural history. The expedition was more than science. It was Europe's first deep encounter with South America's interior, and a testament to international cooperation despite the great cost. What had begun as an excursion meant to take 3 or 4 years ended as a dreadful slog filled with hardship, distrust, and despair. And in its conclusion, there was a final twist of fate. Their sister expedition in the Arctic Circle had been first to return to Paris, already confirming Newton's hypothesis.